S1000 repair part 2, because I bumped the camera and it went out of record mode, so I don't have any video editing software. So if I can get this joined on to part 1, I will, of this second video. If not, you'll see it come up as an additional. So diving back in, we've got the power stage circuit board out of the S1000. Pretty simple procedure, 3 screws. So looking at the circuit board, repairs aren't always as obvious as this one. Sometimes you can be looking at components and circuit boards and everything looks absolutely fine. Now with capacitors, you look for leakage, which is the electrolyte, which comes out over time, generally in their later years, as they run up a lot of hours, which samplers generally do. They're outboard, they sit in racks. Very often the studio's turned on. There's often quite a lot of heat in those racks from other devices, and heat isn't ideal for a lot of these components. So I personally think that they've done a really good job considering how old these units are. So most of the time, the circuit boards and components can look fantastic with capacitors. Even though the unit has failed, capacitors, you look for a couple of things. One is leakage, but initially you'll have a assessment for bulging. Now capacitors, as you can see here, the tops of these, they're segmented, okay, and that is so as the capacitor starts to fail, and it's an indicator for the user or the service technician that the device needs to be, the component needs to be replaced. Sorry. So what usually happens is the top of them, you'll see a little bit of bulging, and it really depends. I've personally found that some capacitors which have failed tend to bulge more when they have less leakage. These ones have just shat themselves. I mean, look at the bottom there. It's just filthy. Look at all this goo and gloop that's around the base of the caps, okay? These things have pissed themselves big time. In fact, the whole board is pretty gooey. You look at the end here. Look at all this gunge. I mean, that is a huge indicator of component failure. This is slightly unusual. You normally see a little bit of it around the base of the components. You don't normally see it so obvious and so widespread as this. So this one's, obviously needs some TLC. So what I would recommend doing, well, I'm just going to explain what I'm going to be doing on this circuit board here, is I'm going to be not even testing these capacitors. These are original caps. New ones are a different size, different color, and we'll get into that. But I'm going to be desoldering them from the circuit board, and I'm going to be looking at other components that I'm going to want to be changing. I've personally found that the resistors are generally very resilient to age and use, so I tend to leave them in place. You also look for heat affectation and damage around the feet of components, and that is basically a discoloring of the circuit board. For instance, if we zoom in here and you look at the circuit board around, for instance, these resistors on the left hand side, components, chips especially, you'll see a discoloration around the feet of them. And if that's often something really good to look for if you're diagnosing and you can't see anything else. You could even have changed the caps and still be having dramas. So that's what you look for. We can't really see a lot in the case of this board because it's just so filthy. It is mank-y. Manky. So what I will be doing in this case is desoldering these capacitors. I'll be taking pictures of the positions and I'll be writing down the values. Sometimes you can't read the values until components are removed, but certainly take pictures as you go, because it's very, very easy, especially if you pause a job to do another job, that you come back to it and you're not sure where something is. Some circuit boards have the values printed on. They also have the current flow marked on them as an arrow or a plus or a minus symbol. Some don't. So take your pictures. So yeah, what I'm going to be instructing you to do, advising, is that if you are competent and it isn't a very hard job, is that you record your values of the caps, check your fuse. You know, I've seen, you might not even have to remove caps. I've seen leaky units still run. It's ideal to be changing them. So if you do see any leakage, just change them out. So you're going to be probably doing two things when you do a repair like this. You're going to be getting in there and doing some diagnosing, which is what we're doing now. I've been in it before. It was a long time ago. I've repaired a lot of units since then. So I could have forgotten things. Do some diagnosing. When you get in there, look at the fuse. Take the fuse out. Even if it looks good, put a meter across it. Check continuity. If it's failed, replace it. See if the unit powers on, because that can help you in being informed whilst you're doing further repairs. And so looking at the components, then you're going to want to basically, let's just say only one looks bad. Okay, it looks really obviously leaky or bulgy, and you go, the other ones, oh, they don't look too bad. Change them. Because these things, they're hour rated, so they have a maximum hours that they are designed for, and the majority of them keep working way after that, but they start to do their job less well over time. So get them out, you're in there. This is going to take some time because the majority of you aren't going to have a library of components to just reach to and bang in there. So you're going to be recording the values of the failed components, or the components that you suspect as being failed. And then you're going to be going online and you're going to be ordering capacitors. And there's loads of really good websites out there. They make it pretty easy. One thing I will say is these days you will find that the capacitors are a different size and probably a different color. The color is company branding. Very often they're blue these days, or purple, bluey purple these days. And also your values you will find that you may struggle to get to match the value of the component that you're changing. And the dumb thing is to overrate. So, you know, can it do the job? Well, it's rated at this value to do the job. Being rated higher very often means that the capacitor can still, it can do that job and is rated to do a job with higher demands. So don't be afraid to put a components in of different value, but don't take my word on that. It depends on the device. Get on YouTube, hit up some of the guys that have got channels on there, and type in capacitor values and replacement, and you'll find some good stuff. I'm just a novice. I just get in there and do what I can do, you know, and I refer to YouTube myself. So I'm going to pause this video, and we're going to remove the chassis from the back of the circuit board, and you can see there that we've got a screw on the back that is going to need to come out. We've got a screw holding the PCB in at the top, and you can actually see a screw that's in the lower third of the circuit board that's going to have to come out, and those last two are from the other side. You can see the damage. I mean, look at the leakage here. Look at this electrolyte leakage here. This is so obviously just a screamer for cap replacement, and look under there, just been oozing out. Something that you might find useful if you're not keen to do this and you want to order a board from the internet, and these are quite well priced on the internet, is the actual details of the unit. So it's called a P30-5, 5 volt 6 amp. This is made by Elco. This is an original, and you can just swap these in basically for a completely different unit. I personally like to change caps. I like to try and keep things as original as possible. Also saves a bit of money. Also, you learn more as you're doing that kind of thing. So I'm going to get these two split, and we'll continue from there. Okay, this pin here, mounting rod, you don't need to undo that screw on the back. The circuit board is designed around that leg. Okay, that's just a mounting pin, so we can leave that one in place, that screw. So that means that to split the circuit board from its chassis, you need to operate the screws from the circuit board side, which we're going to do now. So you can see, can you? You can see this guy here, which is earthed down as well, with a little plate there. Let's get that one out. We'll loosen it off anyway. And it's going to tilt this camera. I'm going to loosen that one off there too. And let's get these out. Doing this on its side just to show what I'm doing. Normally it would be flat. Things might be a tad easier. Don't lose your screws. Don't get them mixed up with the chassis screws either. That one there. Let's get that one out. So there you go. You can see it. That one is out. That's a coarse thread. That screw. Focus, you bastard. So the top one was a fine thread up here. Screw in the middle is coarse. It is easy to mix them up when you're putting things back together. Okay. So let's have a look at if this thing's going to want to come apart. I don't even remember. Give it a little wiggle. Yep, and as you can see, it's coming apart. So we'll... Oh, yes. I honestly did not realize that this thing was this bad. So let's have a look. Yeah, soupy. So let's get rid of the chassis. Oh man, it's one of the worst I've ever seen. Look at that gloop. That's electrolyte, okay? And that is just minging. What a effing mess. So that's going to have to be cleaned off the board. Circuit board cleaner. Look it up. Get that on order. Order that stuff up if you haven't got it with the components that you're going to need. So let's have a closer look at the values of these components. So big guy here, big cap here, 400 volt, 180 mic, U-pharynx, okay, and orientation markings there. I think I ordered one of these up the last time I did a repair, and it was only for one unit. The other ones, it was fine. Yeah, they're pretty resilient, these guys. Also, this large capacitor, you will find that if you struggle to get the same diameter, that is not going to seat properly. It's got some other components right next to it there. Some more caps there, a cap and a resistor there. So you might have to have long legs. So in other words, you don't cut the legs short in order that you can actually have it sort of leaning over. You put some heat shrink on its legs or its terminals so they don't contact each other, and you just lean it. So not sure about the diameter of those nowadays. Looking at these ones here, I'm just going to tilt this camera so we can have a good read. Okay, and I'm going to zoom in for you. Here we go. What are the values of these things? This is what you want to know. I'm going to move the light so we can actually see them. And just come in a bit. There we go. All right. So at a glance, they look to be the same value on all these same height caps. We have 10 volts, 2200 mic. Okay. And again, your orientation marking down the side and negative markings there. So that's the top one. We're reading that. I'm just going to confirm, and you'll be able to do this more when you get them out. I would recommend removing the capacitors, confirming the values before you order, because sometimes you get it wrong trying to read the details off the side. So yep, there's 4 of those of that value. So let's go on to the smaller cap at the back. I'm going to lean this guy over, and we need to try and read those values. Okay, different values. So that is a 35 volt, 220 mic cap. Okay, 35 volt, 220 U-pharynx. So that's pretty simple. Down in the bottom there is another guy. Oh, that's a winding. I'm not sure if that's a choke or what that is, but don't ask me on that one. Okay, you can ask me, but you get I don't know. So it's just like I said, it's just soup. We've got to get these caps out. We've got to get the circuit board clean. Order up some circuit board cleaner. You might find something which removes flux as well as electrolyte deposit. So you're going to be needing to order 4 10-volt 2200 mic capacitors. Watch your diameter on them again. I will probably pause this and tell you what these are. These look to be about 12 mil diameter. I'll get my vernier out in a bit and we'll check on that one. Hey, the video's gone yellow. Cool. And you're going to need to order 1 times 35 volt 220 mic capacitor. If you're keen and you want to replace this guy as well, 1 times 400 volt 180 mic capacitor. Big bastard. I'm going to pause this and I'm going to get my vernier and I'm going to give you some actual dimensions because that could be very useful for those of you ordering. Measure time. Digital calipers. Very handy. So, and these are plastic ones. It's non-conductive. The larger capacitors, 12.5 mil diameter. All of them are the same. The smaller capacitor, the 35 volter, 8 mil diameter. Now, the 8 mil diameter 35 volt cap has some room around it. Okay, it's got some real estate. You can see there. The 10 volt caps, they're pretty close to each other. And you've also got what looks like a choke down there. It's touching them. So you're going to want to try and stick to 12.5/13 mil if you can. If you can't, you're going to have to just find a way to make them fit in that space. So moving right along, we've got to get these guys out because I don't like to order until I've got things out, because sometimes you'll find something else whilst you're carrying out that process. So we are going to flip this board over, mark up the feet of the components that we need to desolder and desolder. So for desoldering, just while I get my pen, desoldering, you want to make sure you've got a good hot iron, soldering iron, preferably one with variable heat control. I find that desoldering is pretty hard. It's pretty difficult. There's 2 ways of doing it. One is by using the ribbon, okay, the mesh that absorbs the solder when you heat it. It's kind of difficult. I mean, so I've seen some people do it and they're really proficient at it. I am not. The other way is a desoldering station, which has a vacuum function as well as an iron tip which melts the solder. That's the ideal way to do it, but you know, you've got to invest in that. But just be aware. Let's flip this guy over. Be aware that it is easy to lift the track when you're desoldering, and by track I mean these silver lines. Okay, that's your circuit rails, if you like, and some of them, as you can see at the top there, they're pretty thin. And then let's say you were trying to desolder this pin, you know, the amount of heat that goes into the area, it can very often cause delamination or lifting of the track, and you'll get a separation of the track from where it's supposed to be. It breaks the circuit. You have to then go in with a repair with a thin piece of wire, and you solder that wire on to the track in a known good continuity position, so above the brake or the lift, and then you solder that wire to its destination, wherever that was. You know, you're probably going to do it, especially if you're new to it, and even then it's difficult. I find that less time applying the iron to the pin with more heat is more effective than a lower powered iron, and you're just sitting it on there and you're waiting for it to, you know, waiting for the solder. And old solder, it can be quite tough. You're waiting for the solder to melt, and even then you're reapplying that heat whilst you're trying to absorb the solder into the absorption tape, and that prolonged heat in the area can can lift the track, the circuit track. So that's just something to bear in mind. So in this case here, we have got to look at the feet of these capacitors, and they are contained within this aluminium heatsink, which is actually a heatsink for this component down here. All right, so that's what that's doing. So we are going to have to look at the leggy legs. Now, I'm going to get a pen and mark them so it's clear. I would recommend that you do the same. It's not the end of the world if you desolder the wrong thing, but it increases the chances of damage. So top pins are, I usually use white, but we've got black today. That's not going to work. All right, so I'm going to get the white marker pen. White pen. This is like a liquid paper pen, so they're quite handy for this kind of stuff. So this one here, that's its legs. Okay. Flipping the unit over, I can see there's one unit capacitor to the right a bit lower down. So that's these legs here. And mark them up. Okay. Put some more on that one. Moving right along, we've got in line with the first capacitor, but lower down. So that's going to be, that's the first pair. That's going to be these two in the sea of gunk. And then the last of the larger rated capacitors is down next to these small caps on the left and the 35 volt cap on the right. So level with just below the first terminal of the cabling. So let's invert that. There's our first terminal. These are probably the legs for the 35 volter, and I would say that these two pins here are the pins for that final cap. So let's just have a look at them. Yeah, see, that's actually offset from that line, slightly to the right. Yeah, so I'm pretty certain it's these two here. Let's mark that up in the swamp. I'm going to call this the swamp. I've never seen a board this bad. Okay, so we've got 1, 2, 3, 4 caps, and we're also going to want to get this little guy out here, and that's just to the right, and there it is. There you can see there's a lot of pins, but you're looking for pairs of pins close to each other, so that's going to be this one and this one. And I can't even see the track to confirm circuit path. It's just so much gunk. But I'm just going to flip it over, and there should be a component above it, about 8 mil above it. It's got a pair. And sure enough, there is. It's that choky winding there. So that just confirms that you're in the right area. These little guys, I'm going to give you the values of these in a sec. Let's just flip them over and look where their legs are. There's quite a lot of legs there. So we've got a resistor to the right. We've got the two caps and then another resistor. So we should have 4 in a group, okay? And here we go. We've got, that'd be a resistor there, because that's the length of the resistor. That's its legs. Then we've got a pair of terminals here, a pair of terminals here, and then we've got resistor, and I imagine another resistor. So I see, we've actually got a resistor hiding in there. So you might want to change these guys too. I'm going to give you the values. Let's zoom in. Okay, what are we looking at? Zoom in a bit more. I can see better with the camera than I can with my own eyes on this one. Let's just turn this board over. There we go. So 50 volts, 4.7 mic. I think that says point there. 50 volt, 4.7 farads. The other one is not as easy to read from this direction. So that's why it's good to get these components out to confirm the values. I'm just going to try and, it'll be the same this other one. You often find that caps that are in close proximity are similarly rated. 50 volts, can't really see. Should you change these as well? I would. Why not? You're there. Get them out. So next stage of this video is going to be desoldering, and it's quite fiddly. I'll do the best I can to show you what I'm doing. And you know, we've got to free up these legs. You can see mark there. The board is now upside down, mind you. And to remove the components. Desoldering. Don't do what I do. Follow some professional advice on this, okay? I find it difficult. Anyway, here is the tape which absorbs the old solder, okay? And pretty simple procedure. Get your iron nice and hot. I start off by laying the soldering iron at an angle so I get more surface area contact with the mound of solder around the terminal. I then wait till it softens slightly. Then I put the tape over that position and I repeat the procedure through the absorption tape. Solder softens and is absorbed into the tape, as you can see there. Right, so that's first one is already done. Let's do the second one. Someone put liquid paper on it. How do that was. So you can see it's softening. Let's get the tape on it. You have to move along the tape because it becomes contaminated. You can see a bit of smoke there. It happens quite quick. That's already soaked into the tape. And I'm just going to do it around the leg of the capacitor. From the other side. You want to be short and sharp with this. You don't want to be hanging around applying heat if you can avoid it. Okay, so why you want a soldering iron that is variable temperature and get the heat up there a bit. I'm on something like 400 degrees. Says almost 40 times 10 centigrade. So that's a bit of a guide for you. Let's just see if I can suck up some more solder there. All right. So we've definitely, I'll put your soldering iron down. And what I'm going to do is I'm going to invert the board and we're going to give the capacitor a wiggle and see if that's now free enough. So you can see as I'm sort of manipulating the capacitor that those legs did pop. That's basically the contact that the solder had. You can see there, it's definitely lifting a bit of solder around it. So there's some more solder to be absorbed on that back terminal. Let's give it another go. Softening it, putting the tape on it, should absorb it. Doing the same on the other side. You can actually see underneath, you probably can't see, but the capacitor was moving. So what I like to do is once I believe I'm getting most of the solder removed and the legs are starting to free up, I heat the area and I push down on the leg and it actually starts to unseat the component. See? I just push that down and it actually pushed the legs through the circuit board. I'll repeat that process on the other leg. So we've got heat, we've got a bit of pressure. And sometimes you have to get long nose pliers onto the actual leg because I've just lent that one over. So I'm going to put the iron down and try and remove that and see if it wants to come out. can certainly see there's a lot of movement there now. And looking at the legs, yeah, there's a bit of work to be done on that upper leg still. Certainly not an expert. Okay. That iron is hot. Is it going to come out? So we've got a plug of solder on the end of that leg. If you can see it there. See that plug? That's just stopping it from... There we go, we've got that off now. That plug contains the track that the pool of solder was soldered to, which I often find happens in this stuff. It is unfortunate when the track lifts. So I'm just heating it up. I'm also twisting the capacitor on the other side with my finger, which is pulling its legs away. And yeah, it is what it is. Okay, let's see if she comes out. No. I'm gonna get some snips. You can look at that. Okay, so I've just manhandled the gloop off the back of that leg. I put a bit of pressure on the first leg, and they're not protruding anymore, so that capacitor should come out. That's out. So there you go. There's a look at what we were dealing with. Pretty well glued in there. Let's read the values of this guy while we're here. So 2200 mic, 10 volts.